Okay, so before I do this problem, I want to remind you of something you might have seen before. You might have seen a situation in which you had two terms that you squared. And what you ended up with was, after multiplying it out, which would result from doing the FOIL method. Let me do the FOIL method. What you would end up with is A times A is A squared. A times B, A, B. B times A is also A. B times B is B squared. And an even more simplified version of that is A squared plus 2AB plus B squared. Okay, so the reason I'm reminding you of that is because I think we're dealing with something that's similar to this. So what we want to do when we get something like this is try to figure out if there's something that we can factor out of the entire thing. I know that each of these is divisible by 5. And so let's start by factoring out a 5. Because 125 is divisible by 5, 400 is divisible by 5, and 320 is divisible by 5. Okay. Notice also that all of these are divisible by S because they all have an S in them. So I'm going to factor out an S. Now that leaves me with 25 R squared because 5 times 25 is 125. Then, because this is bigger, I'm just going to use a calculator. 400 divided by 5 is 80. And this is just the R. It's RS, actually. And then let's check 320 divided by 5. Is 64. And that's S squared. Okay, so let's see how this compares to the work that I just did over here. Notice that 25r squared is a perfect square, just like a squared. In fact, the square root of 25r squared is 5r. So the 5r is very much in the same position as the a squared. I'm sorry, as the a. Notice that 64 is also a perfect square, and the square root of 64 is 8. Now, the square root of s squared is s. Notice that the 8s is very much in the same position as the b squared. Okay? There's another thing I want you to notice. When you multiply 5r times 8s, you get 40 RS. When you multiply the A and the B in this case, you get 40 RS. And if I double that, you get the 80 RS. Okay, so why am I pointing this out? They're asking us to factor this somewhat complex expression, right? Well, whenever in the past you've multiplied this, what you ended up with is something we call a perfect square trinomial. Okay. And in fact, what we have in this case, ignoring the 5s out here, we have a perfect square trinomial. Now, one clue that this is a perfect square trinomial, if you check the first number and you can find its square root, and if you look at the last number and you can find the square root easily, you probably have a perfect square trinomial. And so, even though we went from this expression to this answer, which we call multiplying, you can go in the other direction from here to here, and actually I think it'll be easier if we go from the perfect square trinomial. Let's go to this. When you go in that direction, what you're doing is you're factoring. Which is what they're asking us to do, right? So what I'm going to do is put parentheses and pluses Now, I still need this piece. And I'm going to put the 5s over here. Now, notice here we have the A. That A, this A, is like this 5R. So I'm going to put a 5R over here. And notice that it shows up over here too. And the B is the 8S. So I'm going to put the 8S over here. Now, this would be good enough actually if you wanted to have an answer. But I think what they might sometimes want you to do is to use a different color, is to write it as 5S times, notice that the 5R plus 8S is duplicated, and so we could put a square. So another way to submit the answer, and this might be what they prefer, is to submit this as the answer. And that, by the way, is compatible with this. Okay, so when you have a perfect square trinomial, the factors will be found by taking the square root of the first and the last. Actually, we're working off of this one. Taking the square root of the first and the last, and then putting them into this form. That's how you work with this problem.